Hi ladies, today we are going to talk about ordered pairs, the coordinate plane, relations, domain, and range. Some of these terms should seem familiar to you. So what you need to do is make sure that you have some lined paper on which to take notes. It doesn't have to be graph paper. You can use graph paper if you'd like. You need your handouts for 1-4, and of course you need a pencil. So the first thing you should do is to go ahead and write down the title of this section. So it is 1-4, ordered pairs and relations. We're going to delve into some graphing. The first thing we need to do is just identify different parts of the first quadrant, and this is the first quadrant of a coordinate plane. So as you can see, we have the y-axis right here. It's the vertical number line, and we have what is called the x-axis, the horizontal number line. We also have the origin. The origin is 0, 0, and that's where the two axes cross. Of course, you know that. You have seen that before. Some other things to point out. Just in general, let's get the definition of the coordinate plane. Okay. The coordinate plane could also be called the coordinate system, and it's basically used to locate points. A point is called an ordered pair. So here's your point. It has an x-coordinate and a y-coordinate. So for example, if I wanted to graph the point 4, 3, I'd go over 4 and I'd go up 3. And I'd get a little point right here, 4, 3. Okay. Ordered pairs can be organized as a set of numbers within brackets, or they can be organized within tables. When you have more than one set of ordered pairs that you are graphing, they are referred to as a relation. So this might be new vocabulary for you. Let's make sure we get that down. Basically, it is a set of ordered pairs that go together for one reason or another. Maybe you are graphing a set of ordered pairs that give you the population over a certain number of years. So maybe in the year 2000, there was a population of 100 ladybugs living around your house. Maybe in 2001, there were 150 ladybugs, okay? And I could keep adding to this, but that is a particular set of ordered pairs. You might notice these little kind of funny things over on the side here that I've drawn. Those are called brackets. So let's go ahead and practice drawing our brackets because we do want to make sure that they look kind of nice. They're kind of like sideways seagulls. So if you've ever drawn a seagull flying in the ocean breeze, okay, just turn it sideways. And we have a pair of brackets. They don't have to be perfect, but you need to have brackets around a relation. Just like you always have a pair of parentheses around an ordered pair. You would never just list an ordered pair as being 4, 5. In looking at the relation that I have listed to the left, we can identify its domain. Do you remember what a domain is? It's the set of all x coordinates. It is not the x-axis, so make sure that you get that down. I'm not talking about the x-axis here. The x-axis has an infinite number of numbers on it because it's a number line that goes on forever. So the domain is the set of all x coordinates. Those are the coordinates that happen to be graphed. So in this case, if I were to list the domain, I will use my brackets again. Okay, I would say that the numbers 2000 and 2001 were the domain because they represent the x coordinates from my data below. So what's the range? It's the set of all y coordinates. And again, please note that this is not the y-axis. They don't mean the same thing. The y-axis, again, is a number line that goes on forever. But the y coordinates are their particular coordinates that I was focused on here. So 100 ladybugs and then 150 ladybugs the next year. So I will use brackets again, and I will list just 100, 150. Note that even though I'm using brackets for the domain and range, I am not using parentheses because these are not ordered pairs. These are just listing all of my x coordinates or x values and all of my y coordinates or y values. What I would like you to do now is to just do some practice graphing points. Again, this should be pretty easy for you. Just be careful when you have zeros in there that you use those correctly. But grab your handout, and on page 27, I would like you to go ahead and do numbers 1, 3, 5, 7, 9, 11, and 13. So please do those, and after you finish those, I would like you to do number 15 as well. So basically 1 through 15 odd. Hit pause while you're working on those, and of course you can work directly on the handout. Hit unpause when you're ready to check some of the solutions. Okay, so let's just check these pretty quickly. First, for numbers 1, 3, and 5, I don't have them graphed, but for number 1, you need to go over to the right 4 and up 2. With T, make sure that that is on your y-axis, it's 0, 3, and R should be on your x-axis, so you don't want to have those mixed up. Just check that. For 7, 9, 11, and 13, please just check your ordered pairs against mine. And for number 15, here we have our values in a table, which is a pretty nice and neat way to organize your data. And I've listed the domain and range as well. If you did not list the domain and range, it was because you did not read the directions completely, so make sure that you do that. And I did not graph these points, but I will check them with you tomorrow in class. If you need to fix anything, please hit pause and fix it now. Okay, let's take a look at a real-life situation that focuses on seahorses. They're pretty cool. They are the slowest swimming fish due to their unusual body shape. And to move, they flutter these really tiny back fins up to 35 times a second. So in general, a seahorse can go about 5 feet an hour. That's its rate. What we want to do is make a table of ordered pairs in which the x-coordinate represents the hours and the y-coordinate represents the number of feet for 1, 2, and 4 hours. And then we're going to graph everything and describe the graph. So you can just work on lined paper. In your notes, it's okay if everything isn't perfectly aligned. We'll use graph paper in class. But let's go ahead and see what this might look like. So first, we need to make a table. Your table can be horizontal or vertical. I might do this. X typically always goes on top, Y goes below. X represents, in this case, the number of hours, so I might write HRS over here just so I know that. And the y-coordinate represents the number of feet. Okay. And I want to know the number of feet for 1, 2, and 4 hours. So my 1, 2, and 4 have to go with my x-coordinate in my table because those represent the hours. How do we figure out how far the seahorse has traveled? Well, we need to use the information that we were given about its rate of speed, okay, 5 feet per hour. So in 1 hour, the seahorse goes 5 feet. After 2, we're going to multiply, we get 10 feet. 4 times 5 gives us, wow, 20 feet. It's cruising. What we need to do now is to go ahead and graph the ordered pairs. Since all of these values are positive, we can go ahead and graph in the first quadrant. I apologize for not having straight lines with the devices I'm using. Technology-wise, I can't draw straight lines, but please imagine that they're perfectly straight. So here's the first quadrant. You may go ahead and sketch the first quadrant on your paper as well. We always need to label the x and y axes. The x always goes to the right, the y always goes to the top. And those are not the only things we need to label. You need to tell me what x represents. We know x is talking about the number of hours. So I'm going to capitalize and write hours here. Y represents the number of feet. You always want your label to face the graph, to be inwards, and again, I need to have a capital letter here, just as if I was titling a book. Also, I need to think about how I want to count. You need to make sure that you have consistent intervals on your axes. And what does that mean? just means that you're counting by the same thing. 1, 2, 3, 4, 2, 4, 6, 8. Maybe you're counting by fives, 5, 10, 15, 20. It doesn't matter as long as you're consistent. You can't go 1, 2, 3, 4, 8, 10. You can also count by different intervals on your different axes. So maybe for hours, I want to count by ones. But maybe for my y-axis, if I look at my numbers, I have 5, 10, and 20. I want to count by fives. And maybe I'll do every other dash. 5, 10, 15, 20. Okay, so it's okay to count by different intervals on your axes, just as long as they are consistent. Here I'm counting by ones, here I'm counting by fives. Now let's go ahead and plot the points. I have 1, 5, 2, 10, 4, 20. Okay, whoops. And there are my points. What's missing from my graph? A title. Maybe I'll title this Seahorses. We don't have to have the same exact title, but you do need capitalization, and you need to make sure that your title gives you some information about your graph. You always want to make sure everything is well labeled, because if it's not, people looking at your graph won't have any idea what it's about. Now, let's go ahead and describe the graph. How do you describe it in words? Well, when you describe, you always want to say what's happening as x is increasing. Or as your x coordinates are getting bigger. So what does that mean? Well, it's as my hours are increasing, as my time is going by, what's happening to the amount of feet the seahorse is traveling? It's going up. So you could say that the graph appears to be linear. That just means that all of the points line up. You could also say that as time passes, the seahorse travels farther. So as time passes, the seahorse travels farther. Now we've hit all points. Okay, before you come to class tomorrow, I do want you to complete an entrance ticket. I would like you on page 27 to complete number 17. So all parts, A, B, and C. Bring that to class and we will start there. Thank you. Bye.